Hi, I'm Bob Tabor with LearnVisualStudio.net. Our app works great as a simple soundboard, but we want to push the envelope and enable custom sounds. Sounds that the user can record and reuse. So this is going to require a few changes to our app. In this lesson, what we're going to do is add an application bar with a record button on it. So when the user clicks on the record button, it'll navigate the user to a new XAML page where they can record their new custom sounds. You've probably seen an application bar before, even if you didn't realize what the name of it was. Application bars appear at the bottom of the viewable area of your app, and they contain a number of icons as well as possibly an ellipsis, which when you tap the little ellipsis reveals text below the icon and possibly the menu with additional options. So we're going to see it all work before the end of this lesson. So our game plan in this lesson is, first of all, we're going to use the project template. It already has some boilerplate code that will create an application bar for us. So we're merely going to uncomment out that code and then revise it just a little bit to display an application bar with a record button on it and a menu option to record. And then we're going to work with the appresources.resx files so that the text on our new application bar can be localized in the future. Then we're going to clean up some unused files. The old data model should go. We don't need it any longer. You'll see how it prevents us from moving forward, and we'll get rid of it. And then finally, we're going to wire up and create event handler method stubs for the application bar button and the menu option. I misspoke a moment ago. That menu option won't be to record. It'll actually be able to show an about menu, which we'll handle a little bit later. And then in subsequent lessons, we'll flesh out the functionality for the event handler methods to both navigate to a new page and then show an about message box, I guess you could say. All right, so if you take a look at the main page.xaml.cs, at the very top, there's this sample code to localize the application bar. If you uncomment that out, you can see that it will quickly turn to a red squiggly, and that's because the code it refers to here has been commented out as well. So I'm going to just select this whole thing, and I think I can just do edit and then go to uncomment selection, or you could just hit the chord Control E, Control U, and it will do the same thing. And so that will uncomment this entire section of code right here. Neat little trick there. Okay. And so by uncommenting out these lines of code, we've added a simple application bar to our app. Now obviously we're going to want to change the image that's referenced in this line right here. And we want to use the microphone.png file instead in our assets app bar folder. All right, we want to use this microphone.png file. So I'm going to make that change. So we'll change from that to microphone.png. And then let's go ahead and run the app. And at this point, all we really want to do is just see our new app bar in action. All right, so there it is. There's our app bar, and when we click the ellipse, we see that it has this add. We'll change the wording for that, and then this menu item will change the wording for that as well. But at any rate, we're off to a great start. Let's go ahead and stop this. There is one thing to note here. Just by virtue of the fact that this method is called build localized application bar, it suggests that this application bar is retrieving its textual values from our appresources.resx file. All right, so let's open that up. All right, so let's just change a few of these. For example, I'm going to change app bar button text to app bar about, and we'll change the value to about. We'll change this one to app bar record and change the value to just record. And then let's change this sample property to app bar save, and we'll use this in the future for the value save. Let's save all that. And the next thing that I want to do is I'm going to go back here to this build localized application bar method in the main page.xaml.cs. And I'm going to need to reference the settings that I added in the app-resources.resx file just a moment ago. And in fact, I'm probably just going to have to rewrite a lot of this. So let's take a few moments here. All right, so I changed things around a little bit, but it makes a little bit more sense to me. Let me get rid of some of these. And yeah, we didn't use the constructors in our new application bar icon button and application bar menu item, but we were able to add the icon and the text for the record button icon that appears below it, as well as the menu item. And I have a reason for this, and we'll come back to it a little bit later and you'll see. But at any rate, you can see where I've added the button to the collection of buttons for the application bar and the About app bar to the collection of menu items for the application bar. Now, if I try to rerun the app at this point, something interesting happens. I get an error, and it says the soundboard.resources.app-resources does not contain a definition for sample property. What? What do we do? Well, you can see here that in our main view model.cs, I was pulling a value called sample property from the templated version of the app-resources.resx file, but I deleted that, and since I no longer have it, my old data model code for the main view model croaks on this line, okay? And so now what I can really do is kill two birds with one stone by deleting the old data model classes from my project. So to do this, I am going to go to the view models folder, and I'm careful just to select the old view model code, the main view model.cs and the item view.model.cs, and I'm going to right click and select delete. Select OK. And that should clean up the code base by removing unnecessary code and removes the errant reference to the non-existent entry in the app.resources. So one of my favorite authors uses this phrase that if you stay organized, you can stay productive. So you should be looking to keep your work area clean, like a sushi chef. Always working on using the tools and then moving them to the correct places. So while I comment code out that I don't think I'm going to need anymore, I do want to comb through the code once a day to keep the code base pristine as possible. When I open up somebody else's code and I look at it, I automatically assume that all the code there is being used. However, sometimes there are classes or there are methods that are no longer called. This adds friction and confusion to the process when you give your code to somebody else or when you look at your own code a few weeks after you wrote it. So when I'm not recording videos and I'm actually writing code, like for real, I rely on a third-party tool called Resharper. In fact, a lot of people do. It'll analyze your code and it will find unused classes and methods and point them out to you. And it can also locate duplicate code and recommend changes and 1,000 other improvements to your code. I highly recommend it. It's not cheap, but if you're serious about software development at some point, you might want to look into it. At any rate, this time whenever we run the app, we can see that the app bar will look like what we expect. The record button looks correct, and now we have an about menu box, about menu item rather. All right, very cool. So finally in this lesson, what I want to do is wire up the button and the menu item using event handler methods. And so to do that, what I'm going to do is go back to this code, build localized application bar. And so for, first of all, my record audio app bar button, I'm going to go to the click event, and I'm going to go plus equals, and I'm going to click tab so that it automatically creates that event name, and then I'm going to click tab a second time to generate that handler, the method stub for that event handler in my class. And it automatically creates a throw new not implemented exception, just so it reminds me that we have work to do here. And so what we're going to do is actually leave that in for now so I don't forget. And then I'm going to go down to my about app bar. And I'm going to add a click event handler there as well. Tab, and now I have a new event handler that's been stubbed out. That'll throw an exception if we call it, but at least now we're ready to move forward with our apps. So to recap, the big takeaway in this lesson was how to create a new application bar, an application bar icon, and an application bar menu option. We used templated code and the appresources.resx file, and then wired up event handler method stubs, which we'll fully implement in the coming lessons. So let's keep pushing forward. We'll see you in the next lesson. Thank you. Hi, I'm Bob Tabor with LearnVisualStudio.net. Recording a custom sound in our app would be really difficult to code by hand. Fortunately, we don't always have to write everything by hand. We can rely on third-party libraries to help us build functionality into our apps that would be difficult to do. Somebody's already done the hard work. Let's borrow what they've done, right? So fortunately, your friends at Coding for Fun, specifically Clint Rutkus, the co-author of this video series, has created the Toolkit for Windows Phone that hides the complexity of this functionality as well as a lot of other cool things behind easy-to-use programmatic interfaces. If you're not familiar with Coding for Fun, it's a Channel 9 site that engages in geeky, cool projects, not your standard Battleship Gray business apps. They usually interface with hardware like the Kinect as the interface for controlling boxing robots, or even a Ford Mustang that was heavily modified using Microsoft technology just to prove that it can be done. Make sure you visit and take a look at all the cool little projects that they've created on their Coding for Fun website. Well, Clint is usually in the center of these projects, and he's, again, the author and the curator of the Coding for Fun Toolkit. By using this package in our project, we get some additional tools that we can utilize in our apps, like a little About This App message box, the About prompt, suited for Windows Phone development. So in this lesson, I'm going to demonstrate how to install the Coding for Fun Toolkit package into our app using NuGet, and that is a valuable skill that you need to have increasingly as a .NET developer. But once we get it installed, we'll use it to implement the About prompt as we have already set it up basically as the application bar menu option in our app. So in this short lesson, our game plan is to first of all use NuGet to install the Coding for Fun Toolkit package into our solution. We're going to snoop around a little bit and see what it added to our project. And then third, we're going to add an About prompt to our app so that we can satisfy one of the requirements as we submit our app to the store. Okay, So there are many ways to get to the NuGet package manager in Visual Studio. This time what we're going to do is right-click the references folder in our project, and I'm going to select Manage NuGet Packages. And this will open up the Manage NuGet Package dialog. And so the easiest way to find what you're looking for is to go up in the little search box and type in, for example, coding for fun. And after a moment or two, it'll show you your options. Now, there happens to be quite a few little versions of this. Clint split up the Coding for Fun Toolkit into sub-packages so that developers can just pick and choose the parts that they want in their project. However, for simplicity, and because we're going to use a few different parts of this, and we want to familiarize ourselves with the package in general, we're going to choose to install the complete version. So what I'm going to do is select the complete. I'm going to select the install button next to that option. And now NuGet's pulling down all of the source files that are required to add that to our project. We get a little file readme, Coding for Fun Toolkit exists already in the project. You want to override it? Yes. I think this is just a little... I think that's as a result of the fact that we installed the complete version, which actually installs all these little versions, and it wanted to overwrite that file several times. Okay, but now we can see that it's installed not only the complete, but also these little sub-packages: audio, network, storage, and controls. Go ahead and click Close now. And what I want to do is, in the Solution Explorer, I want to see what's been added to our project. So I'm going to open up the References folder, which will show me all of the references that my project is pointing to. And you can see that the Coding for Fun Toolkit audio, controls, net, and storage have all been added as references to my project. Additionally, let's close some things up here. You can see that there is a new toolkit.content subfolder that has a couple of PNG files, a cancel and a check file, and then also this readme.codingforfun.toolkit.txt file. And so if we open that one up, you can see that it gives versioning information, like what changed, and any migration notes between the versions. Okay. So at any rate, what I want to do is take the simple step of adding an About prompt to our app. So when the user selects the About menu option, we want to display a pop-up. So let's go to our event handler code that we stubbed out in the previous, actually here in the previous lesson. And what I'm going to do is I'll start by creating a new About prompt. Now obviously we're not going to be able to find this, so I'm going to hover my mouse cursor over the little blue cursor and add a using statement to get to the codingforfun.toolkit.controls. So that will add this using statement to the very top of my code file, and we're going to create a new About prompt called About Me equals new About prompt. Very good. Okay, and so there are many overloaded versions of the method that we need. So about me.show, there's actually 3, and we're going to use this third version. So we're going to give the show an author name, the Twitter name, an email address, and a website URL. So let's go ahead and type in channel 9. The Twitter will be @C9. The email address will be ch9@microsoft.com, and then we'll give it http://channel9.msdn.com. All right, and I think that is all that we need. So let's go ahead and run the app. All right, and in the app bar, I'm going to click the About button, and we get our little About prompt with our name, Twitter, web, email address. Awesome, with a version number 2. And when I'm done with it, I can just click the little check mark. Okay, so it's quick and simple, and for this particular app, we probably need nothing more fancy than this. So leveraging open source or even commercial packages is a great way to add features quickly to your development projects. the whole .NET community and Windows Phone development community and Windows Runtime community on Codeplex is built on sharing packages, components, templates, and so on to help each other quickly implement features. So you can save yourself a lot of time during your career by spending just a few hours exploring the work of others before going off and writing your own. Alternatively, you can use the search box on the NuGet package manager like we did just a moment ago to find similar packages and evaluate the strengths and the weaknesses of each one relative to the needs of your project. So to recap, in this lesson, we leveraged the Coding for Fun toolkit to add one small feature now and one larger feature later in this series, as we'll see. We learned how to add packages to our app using the NuGet package manager dialog, how to read the description of the package to learn more, and how packages can be subdivided to minimize unnecessary references and complexity in our projects. All right, so that sets us up nicely for the next lesson. We'll see you there. Thank you. Hi, I'm Bob Tabor with LearnVisualStudio.net. When somebody clicks the little record icon here in our app bar, we want to take them to a new page where we can allow them to record a custom sound. Let's go ahead and stop. I shouldn't have clicked that. And to do this, we need to create a second page in our app and then navigate from the main page.xaml to this new page that we're going to add. So navigation in Windows Phone apps is similar to navigating from one web page to another. And in this lesson, we're going to learn about the Navigation API. And even though our needs are simple, in this particular app, we'll find out that the Navigation API is capable of doing some pretty interesting things with regards to how the Windows Phone 8 operating system will rehydrate apps that were shut down due to memory constraints and rehydrate the previous page that the user was on. So our game plan in this lesson is pretty simple. First of all, we're going to revisit that data-bound project template that we created a little sample of just so we could see whether we wanted to use it or the Pivot app template for our soundboard app. And what I want to do is take a look at how it navigated from the main page to the details page, just so we can learn how it works. And then we're going to discuss the classes that are required for navigation in the Windows Phone 8 API. And then finally, we're going to come back to our soundboard project and we're going to implement the code that's necessary to navigate from our main page to a new page that we'll use and we'll set up in the next and subsequent lessons to actually record a custom sound. So if you remember from a couple of lessons ago, we looked at the data-bound project app template. So what I want to do is actually load a second version of Visual Studio and then load up, let's see, I think it was this one right here, this data-bound app 1. Okay, and if you'll recall, let's go ahead and run the app again. What we were able to do was click on one of these list items in order to see a detail page with the name of the item and its lorem ipsum text, right? And then you can navigate back using the back button. All right, so what I want to do is, go ahead, let's stop this now and take a look at the Solution Explorer. And in addition to the main page.xaml where we spent most of our time, there's also this details page.xaml. It's a second .xaml page in the app. You can see the layout's completely different, the controls are different, and we can look at how it implements this. Basically, the content panel has a single text block that's bound to this line 3 property of the in the view models. You recall it. The load data will add new instances of the item view model, and so we have this line 3 property that we never really looked at or thought about much, but that's what's actually being displayed in the details page.xaml. Now what we're most interested in here is how is it that we're able to navigate from this main page.xaml by selecting one of the items and then go to the details page that actually displays the information about the extra property, the line 3 property of the selected item. And so what we want to do is start on our main page.xaml, and let's focus on, let's take a look at this selection changed main long list selector underscore selection changed property. So let's right click it and select navigate to event handler. And here you can see the code that's required to actually navigate to the details page.xaml. All right. So first of all, what we do is we use this navigation service object, and we merely call its navigation method in order to navigate. However, it has a larger role for more complex scenarios. Since it is solely responsible for navigation between XAML pages, it also allows you to inspect the navigation history, which is called the Backstack. And it'll even allow you to remove entries from the Backstack and then observe the effect that these changes have on the navigation through the app. So to learn about some of the advanced functionality of the navigation service class, you definitely want to check out this article on MSDN. It's called How to Navigate Using the Backstack for a Windows Phone. However, in our case, we merely need to navigate from the main page.xaml to a new page. We don't need to worry about alternate back page scenarios like skipping pages or adding additional pages to the Backstack as the user clicks the back button on their physical phone's interface. We don't need to worry about alternate back page scenarios, passing values between pages, or the like. Therefore, this other article on MSDN describes the process that we're going to use, at least in general terms, in case you want to do a little bit of additional research. It's how to perform page navigation on the Windows Phone. Most of the simple navigation scenarios are accomplished using the navigate method that you read about on that page and that we see here used on this example in the main page.xaml.cs. Now notice that navigate uses a URI object. And a URI object represents a uniform resource indicator. It's similar to a URL, but it has a little bit more utility and is more far-reaching than just a URL. But at any rate, a URI has two basic parts. It has a string representation that represents some location, and then it has this URI kind, go all the way over here to the end, this URI kind that indicates how you should interpret that first part, the location string, all right? So let's start by parsing through that string. You'll notice that part of this string, it's actually constructed, but the first part of it is just basically a literal string, and then there's another part of it that is dynamic. And it retrieves its values from the currently selected item, and it concatenates the static and the dynamic portions with the plus operator, okay? So the first part, the literal string part here on the left-hand side, should be obvious. It's the XAML page that we want to navigate to, in this case the details page.xaml, this file here in our Solution Explorer. Now everything after that, after this question mark and so on, is what's called a query string. And you've undoubtedly seen a query string before, even if you didn't know what it was called. A query string is a means of sending additional information along with the intended page to be loaded. I said that you've undoubtedly seen this before because it's one of two or three primary ways of sending additional data between stateless web pages, and it's used ubiquitously on the World Wide Web. So for example, if we were to open up Internet Explorer, and in Bing, if we were to search for Clint Rutkiss here, you will see, if I pull over the location bar here, that there is a number of information that's appended onto the end of the page that we're looking at, the search page. There's this Q equals Clint plus Rutkiss, and then a QS equals HS, and a form equals QBLH. And some of these things we simply don't understand because they're used programmatically on the back end by Bing.com. However, it's basically just a clever way of passing information from this page to this page, okay? And it's intended to be interpreted and processed by another web page or by the software that is running Bing.com in this particular example. So in the code example that we're examining, when somebody taps on an item in the long list selector, we want to send the ID, the identifier for the item that was selected from the main page.xaml to the details page.xaml. And so the question mark separates the page name from the query string portion of the URL. And the query string is in the form of a name value pair. So here is the name of the query string that we want to send. It's called selected item, and then there's an equal sign, and that will separate the name from the value that we're passing. So for example, selected item equals, and this might turn out to be 1 or 2 or 3 or whatever the item was that was clicked on in the phone's user interface. So the selected item is the name of the pair, and everything after that equals character is the value of the pair. It's probably like 0, 1, 2, 3, 4 in this particular example. So if you were to have more than one piece of information to send, like we saw a moment ago on Bing.com, it actually appended a bunch of additional information to the query string. You use a ampersand character. So take a look at this quick example on screen. We'll see this used later in the series to send geopositional latitude and longitude from one page to another. It'll look something like this, where the query string will be latitude equals 41.8 whatever, ampersand longitude equals 87.623, so on. Okay, this is how you're able to pass multiple values in one string using name value pairs separated by ampersand characters. It's pretty clever. So again, that represents the location, and then what comes after that is an enumeration called URI kind. And there's 3 possible values that could be used here: URI kind.relative, URI kind.absolute, or URI kind.relative or absolute. So with regard to the differences between these first 2 options, take a look at this page on MSDN. It says the following: absolute URIs are characterized by a complete reference to the resource, for example, contoso.com/index.html, while a relative URI depends on a previously defined base URI, so for example, /index.html. So in our case, a relative URI would be relative to the project structure. So when we prefix the URI string with a / character, we're specifying the root of the project's deployment package. That should correspond with what we see in the Solution Explorer. In this case, the details page.xaml is in the root of the project's folder. Okay, and so when this project is deployed, those 2 XAML files, details page.xaml and main page.xaml, will both be in the root of the package, like we saw when we opened up the petsounds.zap as a zip file way back, I believe, in lesson number 8. You remember that? So what about the third option here, URI kind.relative or absolute? Well, it's a bit trickier. The best that I can figure out by looking at MSDN is that we're simply asking the runtime, the phone's runtime engine, to figure it out for itself. It'll attempt to clean up the URI string that we provide and figure out where the resources we're referencing actually are located. So I think we could switch that to URI kind.relative and it would work too. All right, but we'll leave it the way that Clint originally built it. So once the navigation service loads the new page, the details page.xaml, an event called onNavigated2 fires. So let's take a look at that. This onNavigated2 event will fire on the new page that's been navigated to. Now we've already seen this in our app in the main page.xaml.cs file whenever we were binding data, right? We looked at this onNavigated2 method, and I didn't really talk about it a lot at that time. But notice the code here. The navigation context object has a query string object and it has a try get value method, and we send in the name of the name value pair that we're trying to retrieve, and it will give us back in the out parameter, if it's successful, the selected index, so the value of the name value pair. Okay, so that's how we send data to the next page by using a query string like so, and then this is how we grab the data out of the query string like this, and that will give us the value that was passed in. That'll allow us to determine which of the list items here were selected by the end user. So now that we've seen a full-fledged navigation example at work, we're better prepared to tackle this in our own project. So let's go ahead and shut this down and get back into our soundboard app. Go ahead and first of all start by creating the new page that we want to navigate to. And so I'm going to call that recordaudio.xaml. So I'm going to right-click, select Add, New Item. I'm going to make sure to add a Windows Phone portrait page, and I'm going to call this recordaudio.xaml and click Add. Before we jump here, back in the main page.xaml, we want to revisit the event handler method stub that we created several methods ago called record audio the record audio click. Actually, we want to look at that in the main page.xaml.cs right here. Okay, so this is the event handler for the record button on our app bar. And what we want to do is I want to replace that exception with the following line of code. Navigation service dot navigate, and we're going to pass in a new URI, and that new URI will have two parts. So we're going to choose this overloaded version. It'll have the name of the page, so in our case recordaudio.xaml, and then URI kind dot relative or absolute, right? All right, so hopefully this version will be dramatically simplified when compared to that hairy example that we saw a little bit earlier in the data-bound app template. When we create a new URI object with a simple address to our recordaudio.xaml page, and then we use the URI kind dot relative or absolute enum value. So let's test that and just see if it works. Let's go ahead and run the app. Okay, so let's go ahead and click the little record button, and you can see we navigate to our new page that we just added to the project. That's awesome. What we'll see when we tackle a whole other project is how we'll expand on this to actually pass data like the latitude, longitude that I referenced a little bit earlier in this lesson in order to pass data between two pages. But we'll come back to that much later in this series. All right, so to recap, the big takeaway from this lesson was how to navigate between XAML pages using the navigation service. We learned what a URI object is and how to specify a page location and even pass parameters between pages. And we also looked at what the URI kind enumeration options mean and so on. All right, so we're getting closer to actually now fleshing out the functionality of recording a sound on this new page. We'll start that process in the next lesson. We'll see you there. Thank you. Hi, I'm Bob Tabor with LearnVisualStudio.net. Now that we can navigate to the new recordaudio.xaml page, it's time to focus on layout. If you recall from our low-tech mock-up UI sketches that we did earlier in this series, we envisioned a simple reel image, like the reel-to-reel tape recorders, that would rotate to indicate that the app was currently in record mode. So there would be a button to start the recording process, and a button to play back the sound. And then finally, there would be an app bar button that would allow the user to save the file and give it a name. So in this lesson, we're going to get started with that whole layout and that whole process by laying out the page, adding the buttons and the reel in XAML, and then we'll worry about the actual audio recording functionality and the animation a little bit later. So the game plan in this short lesson is pretty straightforward. First of all, we're going to make some branding changes. As you can see right now, our new recordaudio.xaml page just has the boilerplate my application and page name. So we'll at least use localized resources to change the name of the app, and then the page name, I'll probably just hard code that. I'm getting a little bit lazy here, sorry. Feel free to go in and pitch in and do it the right way using the app resources. At any rate then, secondly, we're going to add the buttons, and we'll add an ellipse, and then add some shapes inside of that ellipse to make it look like one of those old style reel-to-reel circles. And then finally, we're going to add an app bar like we learned how to do in a previous lesson. All right, so we're just going to, nothing really new here per se. We're just going to exercise some of the things we've learned previously and get set up for some of the functionality that comes next. Okay, so let's get started. I'm going to stop the execution of this app. We're going to begin by modifying that branding text at the very top in this stack panel. And so the first thing that we're going to do here is we're going to change this text, my application, and instead we're going to bind. So binding localized resources.application title, and then we're going to set the source equal to static resource localized strings. All right, let's go ahead and move that down to another line. Okay, and you can see that it already picked it up and displays it now, the word soundboard. Now, I probably should do the same thing here and go ahead and create an entry for this page name in our app.resources.resx file. However, I'm not going to do that. I'm just going to hard code it here. Okay, I'm just going to put record audio. And again, if I was really going to create this for distribution and I had the intent someday to localize it for different languages and regions around the world, obviously I would take a different tact. I just want to save a little time here. Now let's do this. I want to add the following XAML into the content panel grid. We're going to add a stack panel. And inside of that stack panel, I want to put a toggle button, and I'll describe what that is here in a little bit. Basically, it's just an on-off button, so it has two states, on or off, and you have to kind of click it twice to toggle it on and then off again. All right, and then we're going to add an ellipse, but I'm going to put a grid in here that will kind of take up the majority of our page, and then below that I'm going to put a button, and it'll be our playback button. So once we've recorded a sound, this will allow the user then to listen to it and see, is this what I really want to save, before clicking the save button to actually give it a name, and then they can see it in the list of custom sounds. So inside of the grid, let's make this a width of 200 and a height of 200. And inside of this grid, we're going to put an ellipse. And this ellipse will, let's put the fill equals, and then we're going to use our phone accent brush. So static resource phone accent brush, and close that off, and now we get the following. Very cool. Okay, so our ellipse that represents the reel that we're going to animate is not complete. We want it to look like an old reel-to-reel player. So we can accomplish this by using several smaller shapes kind of superimposed on top of this large red ellipse in the center. through a series of small rectangles and maybe even a smaller ellipse in the very center of it. Okay, so let's start by adding the little tiny ellipse in the very center. So we'll go ellipse, and we'll just go height equals 20 and width equals 20. So let's see what that gives us so far. Okay, you can see it just gives us a small ellipse in the center. Let's set the fill color. I could set it equal to white, but here once again, let's use the static resource phone foreground brush. All right, and that's a little bit more like it here. So let's move these down to different lines. Great. All right, so that gives us a large red circle with a tiny red circle in the middle. Very good. Now let's create a series of rectangles. We'll need 4 of them. One at the top center, one at like 3 o'clock, 6 o'clock, 9 o'clock, and 12 o'clock. Okay, so here, let's start with the one on the very top. So rectangle, go height equals 20, width equals 20. And then we'll set the vertical alignment to the top. And here, once again, we want the fill equal to our static resource phone foreground brush. Close that off. All right, very good. But it looks like it's a little too close to the top here, as you can see. So we're going to need to add a little margin. So margin equals, all right, we'll start on the left-hand side, 0. We want, let's try 20 pixels from the top, and then 0 on the right and 0 on the bottom. And that pushes it down sufficiently. Very good. Okay. Probably what I could just do here, just copy this and paste it, a couple times. And then all we'll do is we'll just change this as we move around. So in this second one, what we'll do, we'll make the horizontal alignment equal to the right, and then we will change the margin to 0, 0, 20. Perfect. All right, here, vertical alignment, we'll set this one to bottom, and then we'll set it to 0, 0, 0. Here, 20 should go there. Is that good? It's not quite right. What did we do wrong that time? Oh. Nope. 20. There we go. All right, and then we'll go horizontal alignment equal to the left, and then we'll set its margin to 20. That should work like so. Perfect. That's exactly what we wanted. Great. All right, so hopefully most of this code is self-explanatory. Let me take a minute to just move everything down onto its own line. I think it improves readability, especially when you have limited horizontal real estate in your viewing area, like we do in this recording. Perfect. Okay, great. Let's save that. All right, so finally, let's do this. We're going to go to the recordaudio.xaml.cs, and you can see here that because of the page template that I selected, I didn't get what I was hoping for. So I'm going to have to type this in by hand, but that's okay. We're going to go ahead and use the name that they use in the boilerplate template called Build Localized Application Bar. The fact of the matter is that we would probably be redoing most of this anyway. I'm going to right click and select generate method stub, and then inside of this we're going to create a new application bar. Application bar equals new application bar. Great. And so create an application bar icon button called record audio app bar equals new application like so. And Then we'll go record audio app bar dot icon URI equals new URI and URI kind dot relative. And so in here, what we'll do is go to assets, app bar, and there's a save. Yeah, right here. If we hover over it, it'll look like a little disk indicating save. So let's go save.png. Great. And then finally, we'll go record audio app bar dot text equals app resources, and we'll use the app bar save. Now, apparently, I don't have a reference to the namespace we need, so yeah, it'll use soundboard.resources. Okay, so that should work now. And then what we want to do is handle the click event equals plus equals, and we'll go tab. All right, and we'll come back to that a little bit later. But now we've set up the click event for our button. The next thing I want to do is add it to the application bar. So application bar dot buttons collection dot add the record audio app bar. Great. And then finally, what I want to do is I'm going to make the application bar. We're going to set the is visible equal to false, so I want it to be hidden at startup. And then we'll show it whenever we have something we need to save, but initially we don't have anything to save. Okay, and I think that's all we need to do. It's going to throw a new not implemented exception if we actually click it. Now, hopefully none of this is new to you. I've explained most of this code before, but you know, essentially we're creating a new application bar and then we're adding a new button to it. We're wiring up an event handler for that button, adding the button to the buttons collection of the application bar, and then hiding it. All right, and then this will, whenever we click on our new save record audio app bar button, it'll fire off this code block. All right, so if we go to if we comment this out and then run it, at least we'll be able to see it. And we'll go ahead and click the record button, and we have an exception of type System Windows Markup XAML parse exception. All right, so this is a good time to talk about what to do when things go incorrectly with your app. Now, I just happen to know, because, well, I have the benefit of editing this video after the fact and edited out the 5 minutes that I stared at this, that I added an extra comma at the end of the margins. Now, for whatever reason, it showed up correctly in the XAML editor, but when we try to actually execute this and it tried to parse through the XAML in order to render it in the phone, it didn't like this extra comma. But then the dangers of copy and paste reared their ugly head, and I made that mistake in several versions of this. Now, I think I caught it in some of the later ones, but at any rate, I've now fixed that problem everywhere I copied and pasted that rectangle code. And let's see if we get it to run this time. Okay, now let's go ahead and click. And we see the little save button pop up. Of course, if we click that, it'll throw an exception. That's fine. All right, so let's go ahead and stop right there. And so to recap, there were no big takeaways per se in this lesson. We're just practicing the techniques that we've learned before to implement the special layout for this particular page. The only new control that you met was that toggle button, which will toggle on and off, and that's as opposed to the typical button that we use where it can only be tapped or clicked once. But accidentally, we got to talk about the dangers of copy and paste and how to kind of look at and examine the exceptions that will happen during debug time and where to look for them. That was a XAML parse error. So where would we look in the C# code? No, we'd look in the XAML. Something was wrong. And so you can start just staring at your code and saying, what looks wrong about this? I mean, it's showing up correctly here. Oh, I see. It's an extra comma at the end. Duh. Okay, those things happen. All right, so at any rate, we'll continue on in the next lesson. We'll see you there. Thank you. Hi, I'm Bob Tabor with LearnVisualStudio.net. In this lesson, we're going to write the code that's required to record the custom sound. So we're going to employ the Coding for Fun toolkit to help us make this a lot easier. However, we still are going to have to come to a fundamental understanding of some things like memory streams and buffers and the phone's isolated storage. So this will be a challenging lesson. I'll speak more about that in just a second here. Our game plan in this lesson is that we're going to modify the toggle button, the record toggle button, and we're going to wire up event handlers for the checked and the unchecked events. So turn it on, turn it off, okay? Then we're going to use the microphone record class in the Coding for Fun toolkit's audio namespace to begin and stop the recording process. And then we're going to look at what happens after we stop recording. We're going to need to temporarily save the sound that's stored in the phone's memory to a location on disk so that it can be played back via a media element, and then also it can be saved permanently so that the user can continue to use that sound from this point on. So the fourth thing we'll do is add a media element control so that we can play back the sound, the temporary sound, and the user can decide whether to keep it or not. And then finally, we're going to manage the state of that play button. I mean, after all, we don't want to allow somebody to click the play button during record. We only want to allow the play button to be enabled when the record button is not currently depressed. All right? So let me just say that this is perhaps one of the most challenging lessons in this entire series because it will deal with some slightly more advanced material. You should embrace this. You only learn when you struggle, and challenging yourself with difficult concepts will help you grow faster. So be sure not only to watch this video, but also read the MSDN articles that I reference throughout so that you get a full background and you understand these ideas as you're working through them. So put on your thinking cap and let's go ahead and get started here. The first thing I want to do is edit this toggle button. So we're going to edit our XAML, and what I want to do is just add event handlers for the clicked and the unclicked, or the checked rather, and the unchecked state of the toggle button. That's why we chose a toggle button in the first place. So here in the toggle button, I'm going to go checked equals, and I'm going to go ahead and give it a name myself, record audio checked, and then unchecked equals record audio unchecked. Okay. And now let's go ahead and just right click and navigate into that event handler. And we'll go ahead and do the same for the other one, so it creates the method stub for each of them. Great. All right, so the next thing we're going to need to do is work with the microphone recorder in the Coding for Fun toolkit. And what we'll do is we'll be using it throughout this entire page. And so I'm going to create a private member variable that'll hold on to the reference to our microphone recorder. So microphone recorder underscore recorder equals new microphone recorder. All right, and you can see that we don't yet have that namespace in our using statement. So let's go ahead, click the little blue line that's under the capital M in microphone, and I want to add the using Coding for Fun toolkit.audio namespace, and that should clear that up. Great. Okay, so we have a new private instance of the microphone recorder class. The next thing we'll want to do is simply go here to our record audio checked, and we're going to start the recording process. So recorder.start, and then recorder dot stop. Is it that easy? Well, yes and no. I mean, there's a lot going on behind the scenes here. But now that we've stopped recording, we have to do a little bit of manual work. Fortunately, a lot of the complexity has been taken care of for us. Now we just have to decide what to do with the data that we've recorded. So as we're recording, the microphone recorder object is collecting the sound information in what's called a buffer. A buffer is simply a pocket of memory that's devoted to storing data on a temporary basis. Buffers are typically used when there's a difference between the rate at which data is collected or received and the rate of speed at which it can be processed. All right, so it may take us 10 seconds to record a 10-second sound. During that time, data is being added to the memory buffer. However, the computer could process that data in a fraction of a second. So the buffer is just a queue. We can write the data at one rate of speed while reading it back at another rate of speed. In programming, buffers usually go between physical hardware and software, or when moving data from memory to disk and from disk back to memory. Or data is coming from memory and going out to a network connection, or data is coming from a network connection and then it'll be retrieved into memory and used in some variable. Okay, so I'm not a computer science guy. I don't understand all the inner workings of how buffers work and why they're needed and all that. All right, so I just tend to think of a buffer as a bucket that you slowly collect things into until you're ready to work with the entire bucket at one time. So, all right, this is a silly example, but hopefully you'll get the idea. I'm walking along the beach and I'm picking up shells and I'm putting in my bucket. All right, and I spend an hour finding shells. But then once I get a full bucket, I want to start processing them, deciding which ones to keep and which ones to throw away, and that'll happen very quickly. So I collect data over a long period of time, and then once I've filled up my bucket, I then process it very quickly. All right, so at least that's how I think of a buffer. Maybe that'll help you out a little bit. So anyway, when we call the stop method, the microphone recorder stops adding sound information to the buffer, but it's holding that information, that data, in the memory buffer. And now we need to process the data in the buffer. So in this case, I use the term process to mean that I want to grab the sound data out of the buffer and I want to place it in a temporary file, a WAV file, on the phone's permanent storage disk, I guess you could say, this permanent storage area, all right? So once it's sitting on my phone's storage, I'll be able to hand that file over to the media element and say, hey, play this, so that the user can hear what the sound that we recorded actually sounds like, all right? So if the user then wants to keep that file, I can rename it and then store it in a different spot permanently. So let's talk about storing files on a Windows phone. The storage space on the phone is partitioned into isolated areas. Each app installed on the phone gets one of these little tiny slivers of all of the storage available on the phone. Now, I use the term isolated because one app can't look at the storage area that belongs to another app. This is for security. One app can't just rummage through your photos or your notes or other secret data and then upload it to some secret malicious server or corrupt it in some evil way, okay? So this isolated permanent storage area that's dedicated to your app is called isolated storage. It's just a tidy way of keeping each app's data safe, since each app is only able to write and read from its own little storage area, okay? So back to the problem at hand here. The microphone recorder object has a bunch of data now. At this point, right here, when we call stop, it has a bunch of data sitting in a memory buffer, a memory stream object, and my job is to save that data from the memory stream object to a file, a temporary file, in isolated storage. To accomplish this, I'm going to create a helper method that will take a memory stream as an input parameter, and then in the body of that little helper method that I'm going to create, I'll create a new file in isolated storage, and then I'm going to dump all of the memory stream buffer data into that temporary file. All right, so that's the plan. So let's go ahead and start building it here. I'm going to create a new private method. So private void save temp audio. That sounds good. And what were we going to use as a input parameter? The memory stream object, because I happen to know that's what is being used in the microphone recorder and what we'll be able to retrieve out of the microphone recorder, and ultimately we want to save to disk, or to the isolated storage rather. Okay, so as you can see, I know we're going to need this memory stream class. However, it's not in our namespaces. It's in the using system.io namespace, so we'll add it like that by hovering our mouse cursor over the little blue cursor under the M and then choosing the correct using statement. All right, so now that we have that, we're going to employ a different kind of using statement. You may have never seen this before, but it has a very important purpose, especially as we're dealing with unmanaged resources like the isolated storage area on the phone. Okay, so here we go. Okay, so there we go. Now, in this context, this using keyword will create a context for an instance of this class. Now, let's find it here. It's actually in the system.io.isolated storage namespace. Let's go ahead and add that. Okay, so it'll create an instance, a context for an instance of isolated storage file. So this ISO store variable. Any code inside of this block that's defined immediately after the using statement will have access to this ISO store variable. So, but once the flow of execution leaves that code block, the ISO store variable will no longer be available because it'll be disposed from memory properly. Now you use this using syntax when you want to work with classes that implement an interface called iDisposable. Now typically these are managed types in the .NET base class library, or in our case the Windows Phone API, and those classes, those managed classes, access unmanaged resources. So the primary use of iDisposable, of the iDisposable interface, is to release unmanaged resources that are no longer needed. So the garbage collector automatically releases the memory allocated to a managed object when that object is no longer used. However, it's not possible to predict when garbage collection will occur. Furthermore, the garbage collector has no knowledge of unmanaged resources such as Windows handles or window handles or open files and streams. So the danger is that two or more processes or two or more apps, okay, they attempt to access the same resources at the same time and cause an unrecoverable error condition. And basically, in this case, crash the whole phone. So types that implement iDisposable handle these scenarios correctly, and that's all that we really need to know. But for a more complete explanation of these topics, I strongly encourage you to learn more about the using statement and the iDisposable interface. So take a look at the MSDN help for both of these. They're well-written articles, and then use that as a starting point. Don't just stop there. Read more articles about iDisposable and why you'd use it, especially in this scenario, and what the using statement helps you to accomplish. We're working with this isolated storage file type called ISOStore. And the isolated storage file class provides methods that help you manage the files and the folders for use by your app in isolated storage for your particular app. Okay, so we use this get user store for application method to retrieve the isolated storage area just for our app so that we can work with a file that will sit inside of isolated storage for our app. All right, so the next thing we're going to need to do is grab the buffer that has been passed in a memory stream and attempt to create a file in our isolated storage area and dump the data into it. All right, so let's do that next. So here we go. I'm going to call this var bytes. It'll indicate the zeros and ones that are stored in our memory stream that we want represented as a WAV file. Okay, so we're going to use buffer dot And I want to use this method called getWave as byte array. Okay. The intent of this line of code is to retrieve values from the buffer and convert it into the format of a WAV file. Now, as you can see, the memory buffer doesn't implement this method just yet. What we'll want to do is use an extension method from the Coding for Fun Toolkit.audio.helpers namespace. So, in order to apply this extension method, we're going to add another using statement at the very top of our code. All right, so let me just go ahead and copy this and go audio.helpers. All right, so there we go. And so an extension method in .NET allows you to attach a method to any data type. So I could add some utilities to the int data type or the string data type, or in this case, the system.io.memorystream data type. So an extension method allows you to work with the members of that type, just like any other public method that was properly defined inside of that class. But we're just bolting another method on the side of an existing class is essentially what we're doing. That's the purpose of an extension method. All right, so let's see. And now it sees it, and it sees that we don't have it called quite correctly. So let's give it what it wants, and that is a sample rate. So we're going to give it recorder.sample rate. Okay. So this is one of those spots where I'm just trusting Clint's understanding of what it takes to convert the memory stream into a WAV file. We have to pass in the sample rate, which is the number of samples of a sound that are taken per second to represent the sound digitally. The more samples, the higher quality the sound, but also the more data that you have to save and the larger the sound file. So here we're just going to pass in the default sample rate for the microphone recorder and then let Clint's code work its magic. For more information about extension methods, take a look at this MSDN article on screen right now. And please note that this is an advanced topic. As long as you understand what extension methods do and what purpose they serve, that's really enough for right now. You can learn later on how to create your own. Okay, so now we have the buffer as a WAV or audio format in this variable called bytes. We just need to actually put it into a new file on the device's isolated storage area. So let's do this. Let's get up here, and I'm going to first of all create a file name for our temporary file. So var temp file name equals tempwave.wave. We may come back and revisit this a little bit later, but for now this will work. All right, so we want an isolated storage file stream called audio stream equals isostore dot create file temp file name. All right, so we're creating a file called temp wave.wave, and that file will be an isolated storage file stream. All right, so now it's ready to accept data, and all we'll need to do is go audio stream dot write, and we're going to write the data. We're going to pour the data from our bytes var into this new file. So since this is an array of bytes, we get to tell it where we want to start dumping the bytes at position 0 and all the way to the end. So we want the entire WAV file, not just little portions of it, okay? So that's what we'll do here, from 0 to the entire length to the end of it. And that's all we'll need to do here, like so. Great. All right, so hopefully that's enough of an explanation to help you move forward. There's a lot going on behind the scenes here, but as a practitioner, I don't have to understand all the underpinnings of how something works in order to enjoy the benefit of getting to work. I just need to know, how am I going to create a file and how am I going to put bytes into that file and then save that file to the isolated storage on my phone. If I can figure that part out, then I can continue to move forward. I can spend, days, weeks, months learning how it works under the hood. That's not important for my purposes today. All right? So after I get that, what I'm going to want to do is set it up to be played by a media element. And so we'll do that next. I just want to remind myself where I'm intending to put that, okay? Okay, so the next thing I'm going to want to do is go over here to our recordaudio.xaml file, and I'm going to add a media element. I'm going to add it right here beneath the content panel grid. So media element, we'll give it a name, and I'm going to also set its autoplay equal to false, and I think that's all I'm going to need to do for now. And then back here at this spot in our save temp audio, we're going to want to go audio player dot set source, and then we're going to pass in the audio stream because it represents a file. And so we're going to, now that we have that file, we can give it to the audio player to play back. We're not telling it to play back just yet. We're just setting its source attribute, right? Okay, so now we're ready to play the sound file. We just need to wire up the event for the play button. So let's go ahead and go over here to our play button, and we're going to add a new click event. So when this is clicked, I want to play audio click. Great. I'm going to right click and navigate to the event handler. There we go. And audio player dot play. Great. Okay, so we've got it all wired up, almost completely wired up here. One last thing I need to do is I'm going to add the call here to the save temp audio, and we're going to pass in the recorder's buffer. Great. Okay, so again, we've got it pretty much all wired up. It's not pretty. In fact, it's very fragile at this point, I suspect. We could easily break the app if we really wanted to. But we'll comb back through this a little bit later, and we will add some defensive code and try to ensure that it doesn't crash under typical circumstances. Again, we'll do that later. For now, what I want to do is test the app. We've written a ton of code here, and that makes me a little bit uncomfortable. I'm always a little bit worried when I write a lot of code and I haven't tested it in small little chunks. But unfortunately, that's due to the nature of the functionality that we've created here. I mean, it wasn't possible to test this in small parts. How do we know that we've adequately saved a file if we can't play it back? Or vice versa, right? So we had to implement it all and then test to see where the problems pop up. So that's what we're doing right now. All right, so this first time through, I almost expect there to be problems with the app. I guess that's a pessimistic way of looking at things, but then I'm not disappointed when things don't work out for me. So let's go ahead and run the app. And let me also say that at this point, you should make sure that you've got a microphone set up with the computer and you know that it works. You could chase down a perceived problem for a half hour and then come to realize that you didn't have your headphones set up correctly in the first place. Trust me, I figured that out the hard way. Okay, so we're going to go to the record, and then I'm going to click the record button, and then what? Well, I anticipated problems, but it just basically bailed out of the app. We haven't seen this happen before. All right, there's a good explanation for this. When you click record, one of two things will happen. Either the app disappeared silently, so you get no error message at all, or you're going to get an exception, and that will depend on which version of the Coding for Fun toolkit that you're using. This is a known problem with it today as I'm recording it, and Clint intends to add a more descriptive error message in the future that lets you know where the real problem's at. Okay, the reason why this doesn't work is because we don't have permission. Our app does not have permission to use the phone device's microphone. To request permission to use the microphone, we need to declare a capability in our WM app manifest.xml file. All right. So in the Windows Phone, you have to request permissions to use certain device capabilities. One purpose of this is to notify the user just how we intend to use their device. They might grow a little suspicious if our app wants to use their geolocation or their camera when that's not the purpose of our app. Our app is just a music player or something along those lines, right? So the way that you ask for permission is that you go to the wm-app-manifest.xml file and you declare the capabilities of your app. And then that will notify the user of what this app needs to do on your phone, and they can decide whether to allow it or not. So in the capabilities tab, we want to look for the microphone capability, and we'll just add that, and that should be the only thing we need to do now. If we rerun the app and we go through the same set of steps, it should work. Now, again, to actually record a sound in the phone emulator, you need to make sure that you have a working microphone hooked up to the computer. You got to make sure the mic works prior to starting this so you can verify that it's not the source of the problems that you might encounter. Let's go ahead and click the record button, and let's go ahead and start. This is a test just to see if this works. This is a test just to see if this works. Okay, I got it. I heard it on my microphone. I think you probably heard it in the video recording if I got it all set up correctly. So it works. All right, we have it saved temporarily to isolated storage, and now we can then in the next lesson or two we'll ask if they want to save it, and we'll give it a name and all that kind of stuff. But at any rate, all right, that was quite a bit of work. I think the biggest issues with our app at this point is that, first of all, the code is pretty fragile and it's going to be easily broken. And so, for example, if we were to click the record button and then click the play button, I think we could probably break it or we wouldn't get the intended results. Let's go ahead and just stop the app right now. And then secondly, we don't really have any visual feedback to let the user know that that we're currently recording, and if something did break, why it broke. All right, and then the third issue I just referred to a moment ago, we're not currently saving the sound permanently. We're not allowing the user to select a name for the new sound and then add it to their list of custom sounds on the page. So we'll fix all of these issues in due time. For now, what I want to do is focus on improving the quality of the code by adding some defensive programming statements. So first of all, let's go ahead and go back to our record audio, and this is where I want to focus the majority of my effort because there's so much that could go wrong right here. I want to make sure that there's actually data in the buffer before we attempt to create a file and fill it up with the buffer's contents. So the first thing I'm going to do here at the very top, even before this using statement, is if buffer is null, then I want to throw a new argument null exception, and I'll add some text here, some feedback. Attempting to save an empty sound buffer. Now, admittedly, this may not be the best error message for an end user to decipher, so we might want to come up with something a bit more friendly and then log this somehow, or ask the user, or try to correct the problem on our own. But this is a good start. At least we're checking for the possibility of null, and then it will alert the user that something went wrong, and hopefully we catch that during a testing phase, like when we distribute this to our friends or as we're using it on our own time, right? All right, so the next thing I want to do is guard against the possibility that the media element is currently playing when the user taps the toggle button to record a sound. So to do that, I need to change a bunch of things in my code. I need to refactor my code, and what I want to do is create the isolated storage file stream as a private member of the class. So what I'm going to do is start up here at the very top, and I'm going to go private isolated storage file stream and call this underscore audio stream. And now I want to add code that'll determine whether the audio stream is empty. If it's not empty, that means that I have data that needs to be saved, and then I need to empty it out. So while I'm here, I'm going to make sure that the media element is no longer playing a sound and its source property is set to null. So this will release any hold that the media element may have on this audio stream from a previous try. it's possible that the media player will keep a reference to the audio stream from a previous recording, and I want to release that reference before I try to create a new file using the same variable name audio stream. All right, so hopefully if that didn't make sense, you'll see what I mean as we make changes to our save temp audio method here. All right, so let me just write this. Be defensive, trust no one and nothing. Okay, and then here what I'm going to do is clean out the audio player's hold on our audio stream. Whoops, stream. Okay, so if the audio stream is not equal to null, then I'm going to clean it out. So I'm going to tell the audio player to stop. Great. Then I'm going to set the audio player's source equal to null. All right. And then I'm going to call audiostream.dispose. Then what I'm going to do down here in our using statement is I'm going to change this around completely as well. We're still going to, actually I'm going to move this out of the using statement because it doesn't really belong in there. And this is going to stay, but this will change. So I'm going to change this to audio stream equals isostore.create temp file name. So now we're using our private version of isolated storage file stream that can be used throughout all of our methods, not just this one method. And then I'll change this reference as well. That should still work. And then we'll want to change this reference as well, and that should still work. Okay, the next thing I want to do is think about how I create and reference this temporary file name here. I want to make sure not to leave old temporary files around since they could clutter up my app's isolated storage area, much like extra files that take up too much space in our hard drives. So the exception here is that your isolated storage is much smaller than a hard drive, and audio files can be very large, so you could fill it up very quickly. So what I want to do is I'm going to start by moving the declaration for our temp file name up here to the top, private string temp file name, temp file name. I'm going to set that equal to temp wave.wave. Okay. And then next what I want to do is replace this line of code here. Go ahead and delete it. And I'm going to replace it with something like this. Put a little more logic here. If the isostore.file exists, temp file name, then I'm going to delete that file. isostore.delete file, temp file name. All right, so that should clean up our file name problem. All right, and I want to create a new temp file name based on the time of day that this is being recorded, the date, time. So I'm going to use string.format, and I'll replace out some things about the file name with datetime.now to file time. Great. And so we will call this .wave. So we'll use the replacement code 0, and we'll replace everything between the curly braces right here with the current file time. All right, so this is just a long list of numbers that are separated with dashes that would be suitable to use in a file name. Okay, and I think that's all I really want to do now. So actually one more thing. I want to disable the play button whenever we're currently recording. So like I demonstrated earlier, we turned on recording and then we hit play, and we don't want to allow that. That simple, what I call state management, should reduce the possibility that the user is able to corrupt something and make our lives as developers easier by eliminating that possibility. All right, so let's do this. Let's go back over here and give this play button a name. We're going to call this name equals play audio. And then come back here and we'll go to save all this. Let's go to the record audio checked. Before we begin recording, I'm going to set the play audio button is enabled equals false. Okay, so that will make it no longer clickable. And then when we stop recording, I'll make it clickable again. So play audio dot is enabled equals true. Great. Okay, so that should help bolster our app, and we can test it out and make sure that these changes work and continue to test it and see if there's any edge cases that will break the app. All right, and I'm sure we could find something. Don't try too hard. All right, so to recap, the big takeaways from this lesson include utilizing the Coding for Fun Toolkit's audio features to greatly reduce the complexity of the phone's microphone usage in order to record a sound. If you want to peek and see what it does, you can actually search for the full name of the class in Bing to find a code listing on Codeplex. And I was able to do that, and I found this web page on Codeplex where the code is stored. And it gave me some insight into how, for example, the record audio, or the microphone recorder class actually works. So that's an interesting exercise because it allows you to see how much that Clint's work has done to reduce what we need to do in our phone apps if we want to use the recording feature. All right. We also learned about the other using statement in C# that's used to properly dispose of managed classes that worked with unmanaged resources. We learned about the function of buffers as a means of collecting data at one rate that could be processed then at a different rate. We used the buffer built into the Coding for Fun microphone recorder class, and we retrieved the buffer to save it into a file on the device's storage. We learned about isolated storage and how it protects each application's storage area, keeping it private from the other apps on the system. And we briefly learned about extension methods. We used one that was implemented by Clint in the Coding for Fun Audio Helpers namespace. And finally, we practiced some defensive programming techniques to ensure that our app can handle some unique situations or edge cases. And there's plenty more that we could do there as well. All right, but that's enough for now. We'll see you in the next lesson. Thank you.